Now, when we deal with forces in two dimensions, that's where things get a little bit trickier mathematically. That's where we have to start thinking of forces as vectors, not just as positive and negative, right and left, up or down, but now we have to include the fact that those vectors might be off at some angle. And one of the best ways to get into that idea is through the idea of statics. Statics is a field that is very important in a lot of cases for engineering. If you end up being an engineering major, one of the classes that you'll have to take in most cases is a class called statics. You'll also take a class called dynamics, but statics is usually the first one, and it's very similar to a lot of what we're going to be doing in this class. It builds on those basic ideas of physics. And so here, when you're approaching problems in statics, it's the same way we've done things before. You identify every applied force, make sure you draw a free body diagram, including anything that actually acts on the object, including the interaction pair, what's causing it. Is it a normal force? Is it a tension? Is it the weight? What is actually causing it? And then you turn that into an equation. Now, if we're dealing with something that's static, the nice thing is the acceleration is always zero. So if you add the forces up, you should get zero. Anything to the right cancels out with anything to the left. Anything up cancels out with anything down. So there you separate those components. You'll write two equations, the sum of the forces in the x direction and the sum of the forces in the y direction. So here's a case. Let's say we know that the tension in a certain string is 540 newtons. And now we want to know something about the rest of the system. Let's say there's a hanging mass m. So if we choose our object, instead of being the mass because it only has the tension acting up on it, if we just look at the tension to be the sum of the forces to be acting at this point here, where there is a tension force acting up and to the left, up and to the right, and then down, we can kind of solve what's going on. Because it's pretty easy to see that if it's not moving, the tension force in this string is straight down and it's equal to the weight of this object. The tension force up and to the right will be at 25 degrees above the horizontal, just by doing a few simple ideas of geometry, and that force will be 540 newtons. And then there'll be another force up and to the left along that 60-degree angle. So to write that as an equation, what you do is set net force equals mass times acceleration. That's not changing. But in the x direction, there is the horizontal component of the 540 newtons, and then there's the horizontal component of the second force. And so you just break those into pieces. And in this case, it's both cosine of the 25 and 60-degree angles. So if you look at it, we would be able to solve for one of those unknown forces in this case. In the y direction, both of the strings are pulling, so they both have an upward component, but then there's the weight of the object that's pulling it down. And so with these two sets of equations, the horizontal motion, the vertical motion, we can solve for any of the unknowns. Because if we know the 540 newtons of force 1, we can figure out what force 2 is going to be. And if we know force 1 and force 2, we know what the weight is going to be. So I'll challenge you guys to try and solve for that. So I'm going to pause here for just a moment, see what you get as you plug that in, and then we'll continue it. So you do 540 newtons, then you do cosine 25 divided by cosine 60, and that gives me 978.8, or about 980 newtons. Then, in the y direction, we plug in what we know, add mg to the other side. So then we plug in what we know, and you end up with a mass, a hanging mass, of about 110 kilograms. So these types of problems, you're able to solve for more than one unknown because we have two sets of equations, the horizontal motion and the vertical motion. Sometimes the algebra will be trickier, but this is kind of the same basic approach in any given system.